Hello, this is Don Schwartz from Marist College, and I'm here with two of my honors students, Daniel Grossman and Tyler Romaldi. And what we want to do is present the research that they did as part of their honors project. So we're presenting developing a scalable platform and an analytics dashboard for manual physical therapy practices using pressure sensing fabric. And as I said at the beginning, this is a result of their honors project. Marist College encourages our better students to complete honors projects, which are self-directed projects supervised by a faculty member. The idea of an honors project is to do something beyond which they would have done in any undergraduate course. And happily, they've done a lot beyond what would normally be expected in an undergraduate course. The work that they've done is in association with the Marist IBM Joint Study and Studio One Labs, who provided the fabric sensor technology that we use.
Thank you, Dr. Schwartz. My name is Tyler Romaldi, and I'll be presenting this half of the project. Currently, there exists an educational gap with training physical therapists. As we learned at Marist College from our physical therapy department, professors and students don't necessarily align on the same page sometimes, and I'll explain. Picture this. I'm pressing down on a joint on some human and trying to do some type of manual therapy. Explaining how much pressure to apply on a given joint is ridiculously difficult to do, especially with no quantifiable information. And without that quantifiable information, you don't know how hard to press down, and you don't have any metrics to tell you to stop. This project is entirely related to that issue, and that is the gap that we're talking about. As you can see here, there's the fine folks from the physical therapy department, and these were kind of some of the people that we were working with. And there is just no visual feedback for them, and it's quite difficult to kind of put that together. And especially working remote now these days, this project has some remote capabilities that we'll get into a little bit later on. But like I said earlier, this project is about closing the gap, and this all started as our honors by contract and expanded into this honors thesis. So closing the gap continued. Our honors by contract, which is a 1-credit research attachment to any course that we had taken related to computer science, started out with this diagram to the right side. It worked quite well, actually. We wanted to expand it quite a bit more because it wasn't necessarily scalable, and it was more of a proof of concept application. As you can see in the red figure, or the greater red figure on the bottom, where it says physical environment at Marist, we have the fabric, which is this pressure sensing fabric that's highly adaptable, sending data through this connector, which is a piece that responds to a Raspberry Pi. This data is flowing dynamically through that pipeline and then gets stored onto Studio One Visual's database. This worked for us very, very well. However, there was a lot of moving parts, and we wanted this to be a real-time data pipeline that really touched only the main entities. And that's kind of what we're bottlenecked at. Additionally, we made some greater enhancements to the virtual environment at Marist College. This application was only scalable for web application sites. So only type in the URL, you go to the website, there it is. We wanted to make it accessible so that way you can have this actually on your physical device and also be able to reach it anywhere on your phone. So that is the enhancements that I'll be talking about in the next slide. But this definitely worked as very, very well, phenomenal actually. But we did want to make those greater enhancements. So in the current state, we condensed that entire big graphic into this one big box. And you might be wondering how we did that. And our new implementation leverages quite a number of new frameworks that Daniel and myself had no idea how to even use before this project, which is definitely a great thing that the honors project allows us to do, which is exploring those new territories. And the biggest one that we think that leveraged the most was Vue and Docker, which Vue lets us have a native application, so something that you can download to your system, use regularly like that, like some type of application, or you can use it on the web. So you just type in the URL and go. That's brilliant because we don't have to code things twice, and it works the same on both platforms. and Docker, which allows us to package this entire thing up and send it wherever we like, where it's operating system independent, which is phenomenal for our work. And if you remember from the last diagram, we had an external database that was not at Marist. That is no longer necessary for our needs and goes right to Marist. So we have minimal moving parts. Some other features that we have are user authentication. So we're keeping track of both the professor or instructor and the students and making sure that their data is correctly associated with a relational database that we use, such as PostgreSQL. We also have dynamic rendering for real-time data pipelines. So all data is rendered dynamically and displayed dynamically, as you will see a little bit later. We also have automatic backups so that way none of the data is lost, and we have a microservice architecture, which we pride ourselves very much in. Anyone that's coming in after us can then simply set up an application running in its own service and its own environment and just point to our API. This allows for a greater workflow as the developer or data scientist does not have to know exactly how the entire application works as a whole, just merely how one part of it works. This will enhance a lot of the development for future development practices. So for comparison, as I had mentioned, we kind of boiled everything down into one big cube. This has been working phenomenal. We're currently trying to go and do some testing scenarios, which should be done in the fall. But this is just a breakdown just to kind of further show you as a viewer how much we actually compiled down into this one big block now.
So hello, my name is Daniel Grossman. I'll be talking about the fabric and some of the visual aspects of how we're representing that data that we're collecting. So the fabric, as you can see here, is about 12 inches by 12 inches, and there's 8 by 8 grid of sensors in it. So we're collecting data from 64 data points in the fabric. The white box you see on the left houses the Bluetooth connection that we're able to leverage to send that data wirelessly. And there is a wired option for if we need it to not have to worry about a power source. The fabric that Studio One Labs provided us here is very useful. One innovative thing that they were able to accomplish is bending the fabric, but not applying pressure to it. Doesn't detect extra high values as it's being bent, whereas other pieces of equipment might do that. So placing it on a weirdly shaped part of the body like a shoulder where it's not going to be able to lay flat, it allows it to still collect data as if it were laying flat on the table. So this is how we've been able to visualize and save some of the data that we're collecting from the fabric. We use the concept of sessions. So to start and stop a recording of the fabric. So in the UI, we have a start button, and that's when the fabric will start collecting data. And as you're collecting data, you can either choose to have it displayed to you visually as you're collecting it, or to just hide that graph as you're collecting it. So the user will start the application, hit the start button, and that will start the fabric collecting the data. Once you hit stop, or if you're collecting it live, that graph will appear as you're pressing on the fabric. Then we have two different ways of showing that data: the line graph, which you see below here, and a heat map, which we'll show in a minute. So the line graph has a different line for each of the 64 sensors, and you can see how different sensors in different parts of the fabric will be highlighted as the professor or the student pushes their hand down on the fabric. The x-axis represents time, and the y-axis represents the pressure applied to the fabric. And the top graph shows the table of sessions, which tracks the history of all the sessions that that user has performed. So the CUID being the ID of the student or the professor, and they're able to give a description about what was done during that session. So this is the heat map for one of the sessions that we've recorded. It's, again, the 8 by 8 heat map of each block corresponding to one sensor on the fabric. So this allows the user to get a sense for where on the fabric they're pressing during that session. So this is one of the more interesting features that we were able to implement, is the superimposing of two different sessions on top of each other. Right here, we have selected 3 sensors from each of the sessions that we are displaying. The solid lines are representing one session, and the dotted lines are representing another session. So here we can kind of see what Tyler was alluding to earlier, where it's difficult to gauge how much pressure is being applied during one of these mobilizations. So you can see how as the sensor values peak and dip down, that's how much pressure is applying during that part of the session. So the students and professors are able to compare their results and see, should I be applying more pressure here? Should I be applying more pressure in different areas? And generally using this tool and other tools to compare how they're performing compared to the professor.
So our novel findings, what we had done was never really accomplished before from what our research has showed. These quantitative metrics such as pressure, the location of necessarily where you're applying this pressure to, and data consistency, these all will help physical therapists and training physical therapists learn better techniques and become better professionals for their future. It's also bringing much more convenience and with remote learning potential. I'm going to do these two topics at the same time because with the current climate, remote learning is critical, and we think that this fabric could possibly help with training physical therapists, especially with the current situations that we're in right now. People can take their own fabrics, train with them using the Bluetooth technologies that are already established with them, and train on their own little pieces of technology that they have themselves, and use this data, and their professors can essentially compare what they have with them. And all this can happen in real time. We think that this is truly novel and will revolutionize the way people learn physical therapy practices.
Okay, so that's our presentation. Thank you very much. This is normally where we would ask if there are any questions. I guess we'll do that virtually. You've got our email addresses down here. And so we want to thank you for your attention.